In the previous video, we looked and saw how to be able to use MATLAB to be able to evaluate a definite integral. In this video, we're going to take a look and see how we can do the same thing, but with indefinite intervals. And the good news is, if you can do the definite intervals, it's a little bit easier to do indefinite intervals. So all we're going to do is we're just going to take the last two parameters, the a and the b that we used before, out of the int function. So now it's just going to be f comma x. So I'm going to show you how to use the int function, and then I'm also going to show you how to format it a little bit nicer than just putting the answer if you want to. All right, so now we need to have a symbolic variable x. So every time we start these, we're going to have one symbolic variable x. I'm going to define our function f to be x squared plus, and we're just looking at this function right here. So we have x squared plus quantity x plus 1 to the 1/3 plus 7. Now I'm going to suppress that. And I'm just going to go ahead and get the answer for this. So I'm going to say int f comma x. All right, and let's run that. And here's our answer. Okay, so it goes through, it does all the u sub necessary, it does all the power rule, all that good stuff. Now, if we want to format this, a couple ways we can do it. We can do an fprintf statement, and we can say the answer to problem 3D, right, since it starts at D, is, and we just do a semicolon and then a /n. All right, so remember, don't use \n. We don't want that because it's just going to print out \n. If we want to go to the next line, we want /n. All right, we're going to close out the apostrophe, and if we run that, it's just going to preface the solution with an answer to. Another way to do this is if you want to define, so I'm just going to move the int function up, and I'm going to define it as maybe p1 equals, and then suppress it. So now I've assigned it to a variable, and I can do down here and use %s for string in the fprintf statement, and then I'm going to say comma p1 as the parameter, similar to what we did with the approximate 6 decimal places back in the first series. We can run this, and it says the answer to problem 3D is the answer to the integral. So we can set it up really nicely in one line. All right. We could do this for the other functions as well. All right. So we have the integral of tan plus or cos of x. And if I want to, just for my own sanity, I can define this as problem 3D, right? And I can define this one as problem 3E, right? Remember, the percent means that we're commenting, so we're not going to execute anything. So we're going to say, let's say G is going to be equal to tan of x plus arc cos of x, right? Remember, arc cos is a cos of x. And I'm going to say P2 is going to be equal to int G comma x. And then finally, I can use the same fprintf statement. So I'll just copy and paste it, except I'm going to replace this with 3E, and I'm going to call this P2. Right? And then finally, I could say problem 3f, and I can define a function h to be quantity x plus 6 for the numerator. So we're just looking at this function over here, or this integral, divided by quantity x squared plus 6 times x plus 8, right? So remember, you have to define all multiplication explicitly in MATLAB. Right? So that's our function h. And then finally, we can assign that to a variable p3 to be int h comma x. And we can go ahead and do an fprintf statement. I'll just copy and paste that. And we'll say the answer to problem 3f is P3, right? So when I run this, I should get 3 lines that say the answer to, the answer to, the answer to. So let's run it. So there's 3D, 3E, 3F, all right? So really nice and neat. If you want to put an enter in between those, what you could do right here is you could do an fprintf, and you could just say /n, right? And what that'll do is that'll just put an enter in between each of the problems, all right, if you want to. And so let me show you what that would do. All right, just so that way the text isn't so dense when you read it. Might be a little bit more visually appealing on the eyes if you choose to do that. Okay, so hopefully this shows you how to be able to use MATLAB to be able to graph the area bound by a function of the curve, and then to be able to find or evaluate definite and indefinite intervals. One last thing to note is that with the indefinite integrals, it does not put the constant of integration. All right, so notice there's no plus c, no plus c, no plus c. So if you ever use this in real life, just be cognizant of the fact that you might need to add that plus c in there.